This is a Marconi Model 2024 synthesized signal generator. It has a range of 9 kilohertz to 2.4 gigahertz and has the option 11 of fast pulse and high power, and option 4, a high stability time base. It is supposedly in non-working condition. Cosmetically, it's in pretty good condition. It's a little dirty, needs a little cleaning. So we will investigate this and hopefully repair it. So if this interests you, stay tuned. Alrighty, let's get into this. I picked this up pretty cheap, and it's a real nice machine. I don't know what these sold for new, but I would imagine many thousands of dollars. I don't even really know how old it is. I should look that up, but I don't know, 1990s, early 2000s? I really don't know. But I got it plugged in to our kilowatt meter, and it's on current draw settings, so I got it plugged in. Let's turn it on. Well, the cooling fan inside has come on. The screen is backlit, but there's nothing on it. So I did a little research. This is what the picture of it turned on looked like, and I guess there's an issue with these display screens, and hopefully we can get it repaired, and it'll be a nice item. But the screens I've seen that are non-functional, there's at least some lettering on it that's kind of broken up with lines in between it. This one's completely blank, so I don't know. Hopefully it's not a couple $100 doorstop. So we'll get the cover off, have a look inside, and we'll be back. Okay, we got the cover off, and I hope I don't jinx it, but a very good sign. All the screws had washers. None of them were missing, so this thing has been opened up before because the calibration stickers were broken. So there's so we'll get on to the power supply, which is always the first thing you check. So I have a little cheat sheet here I made, and we have this plug here. I'll show on the close-up camera. So we got orange, black, red, yellow, and gray. So the orange is 5 volt, red is 12 volt, yellow 24 volt, gray minus 12 volt. So we'll go through, and and the black is obviously ground. So we'll fire it up and try to measure the voltages without shorting anything out on camera here. Or electrocuting myself, for that matter. So that's empty. 24 volts. Yeah, yellow. minus 12, 7 volts. Wait, is that the black one? I can't see. 7.69, the fourth one. We'll check these others. 5 volt. Orange is 5 volt. Oh. Oh no, that one's not populated. So that's 7 volt one. Let me see. That one is the fourth one down. So we'll check. 5 volts, right? 5 volt. That should be ground. Ground. Well, that's the red. Red should be plus 12? Huh. So the 12 volts, the one that's missing, positive 12. So there is a power supply issue, or something that's drawing the 12 volt rail down. So I haven't really investigated any further what's what. So let me get into the schematics and we'll be back. All right, I took the shielding cover off the power supply. I got good news and bad news. So the bad news is the service manual I have for it does not have the power supply schematic in it. Evidently it's a Lambda Coutant power supply board. I guess they made 4 or 5 different power supply boards for this, so that's kind of discouraging. But when I looked around, I don't know if any sharp eyes have caught it yet, but let me put the close-up camera. Look at that there. That's a bulging capacitor. Bulging, not good, obviously. So, doing a little research, evidently these Lambda Coutant power supplies had issues with capacitors. So we'll need to do a full recap on this, but I think I might try just replacing that one and see if that fixes it. These other ones are kind of strange. Oh, you can't see the other ones. These big ones are, what are they? 100 microfarad, 250 volt. I don't have those kicking around. So, yeah. Boy, hopefully it's just a power supply issue. If it's other stuff in here, that's not going to be good. So let me get this power supply board out and we'll be back. All right, we got the power supply board out, and that is our cap. So I did a little trace in here. So this is our ground. This is our 12 volt supply. Our cap is right here. So it goes positive, negative. This is our capacitor. I forget. Oh, that's a connector going down. It goes to a choke and out to our 12 volts. So it would make sense that our 12 volt rail would be affected by that capacitor, hopefully. So that is a Nippon Chemicon EXE series. That's a low impedance capacitor, and I happen to have UPW low impedance capacitor, and the specs are actually slightly better than the Nippon Chemicon. Slightly lower impedance and a little better ripple current. So I'd like to just replace that one and see if it works, but I'll tell you, it was easy to get out, except this damn connector is really a pain in the ass to get out. But I don't have these oddball 250 volt caps, so I guess I'll just have to bite the bullet, replace that cap, and try it out. And the reason I want to try it out is just make sure there's not other stuff going on with it. I don't want to recap this board if, like I said, this thing is a boat anchor. So we'll pop that cap out and test it and see what we got. All right, and the drum roll for the test. So we got testing. We got 47 ohms of ESR, and the capacitance is down from 1,000. So that one was bad. So we'll get our new one in. And I guess I'll pop it back in the board. Or I mean in the, put it all back together and see if it works. Okay, we got everything put back together, and we'll try it out. We'll see what our 12 volt measurement is, and I took the screen out so we can get everything in frame here. So we got the probes hooked up to our 12 volt rail and 11.78 volts. I don't know if that should be just a pinch over 12. All the other voltages were a pinch over what their rating was, but that should be enough to make the screen work, I would think, if that was indeed causing the screen issue. So it evidently wasn't. So I wasn't convinced, or as of now I'm not 100% convinced that it is the display that's bad. So I was wondering a way how to test the screen, and I posted the question on the EEV blog, and someone had mentioned putting a shortwave radio by it and see if you could pick up interference. And then I got the brilliant idea. I have a little tiny SA meter, and we will turn that on and run it across the screen. I have it set up to a 1 to 10 megahertz spread, and we come away, everything goes down to nothing. But if we lay this across the screen, we're getting something. So I think the machine is communicating with the display. Yeah, there it goes, but much better. So I think it is the display, and I just went ahead and ordered a replacement. So let me get things set up and we'll be right back. Okay, before we proceed, I just wanted to go over my research on this Marconi. I found it on the interweb, and I mean the one for sale. That, like I said, was reasonably priced. Hopefully that'll turn out to be right, but anyway. So when you type in the Marconi 2024 model, about the third or fourth Google result down brings you to the quick repair project at the EEV blog. So Grumpy Doc, who seems like a pretty smart dude, picked one of these up, and his display, as I had mentioned earlier, when I did my research, his had some characters, but they were lined out and not clear. So he goes on to talk about his repair, and what evidently happens is this ribbon cable is one of those glued-on deals that tend to fail over time, and they don't make contact with the screen. So in his research, he found that that screen was had a T6963 controller, and he found a replacement based on that controller, and as you can see, it is working, which hopefully that will repeat in our case. So we have to make a ribbon cable adapter, because the display in there was let's see, it was 20 a row of 20 pins, and these replacement are 2x10. So we need to make a ribbon cable that will connect to that. So we'll get into that and we'll be right back. All right, real quick. So this is our old display. It's a Optrex DMF 5010 that uses that T6963C controller, which is made by Toshiba. And this is our replacement. It's a New Haven display. It's a NHD, what is it, 2406 4WG-ATMI-V. And I got that at DigiKey, and it uses the RA6963 controller. And I got in a little bit of a panic, and I went and looked on the interwebs, and it is indeed a drop-in compatible deal. So I didn't look at that carefully. I just saw on DigiKey it was a 6963, and luckily it hopefully will work out. So we need to get the ribbon cable adapter set up. So let me do that. And on the old screen there was an electrolytic that had like 67 ohms ESR. I replaced that, and that didn't fix it. So anyway, we'll be back. All right, we're ready to do the tedious task of making this adapter cable. So I took the end off of our ribbon cable here and stripped the ends. And this is our pin rack. And I'll show you a close-up of that here. So I wound these little coils to stick our ribbon wire in, and I think I'll make it a little bit easier to solder. Then we'll slide some shrink wrap over that, and I think that'll work. One thing I wish I would have paid more attention to is this ribbon cable. The wire in it, I think, is 28 and 28 AWG, and I wish I would have got a little stouter wire, but I think it'll be okay. I don't think it carries a lot of current or anything. But let me see if I can get this soldered up, and we'll be back. Just real quick, I went and tinned the wire on this connector that we're going to make, and because it's twisted wire, it's very fine wire, and it frays real easy, so I think it's a very good idea to tin the ends. So I'll try soldering it, and we'll be back. Alrighty, it's the moment of truth. So we got our ribbon cable done. I pulled the 5-volt power supply going into the inverter board. The other display had fluorescent backlight. This is LED. And then I got a 22 ohm dropping resistor. And Grumpy Doc used an 18 to get the 80 milliamp current draw, but I don't have an 18. 22 is closest I have, and that brings it down to 70 milliamp draw. So, oh, and I did forget to mention, when I wound those coils for making the ribbon cable adapters, is a coil winder. It has a winding end and has a unwinding end. It's very useful in vintage stereos. So I think I got everything ready. I'm really nervous. I say 50-50 chance it works. Although there's probably only a 10% chance at that. So here goes nothing. Ha! Ah! What do you know? Oh, I don't think you can see it. It works. It's upside down. Ha 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 ha! Woohoo! Yeah, it definitely needs a lower dropping resistor. It seems kind of dim. Let me get a better view of that. Hang on a sec. All right, we'll try that again. That's yeah, it's not very bright. But son of a biscuit. That, oh man. When the screen was completely blank on the other one, and the others I've seen where, you know, you at least could see some characters, I didn't know. Wow. That is so cool. All right. I I need to get the power supply for the LED more permanent, and we got to figure out a way to mount this into here because it's considerably smaller. So, oh man, I am happy. All right, we'll be back. All right, I'm such a dumbass. I didn't have the breadboard right. The backlight wasn't even on. So I thought something was weird with that. So yeah, we got a good display. Very cool. Very happy. Good Christmas present. All right. We'll be back. All right. On to our backlight power supply. So this is the board here, and it had this inverter board on it. So we took that off, and I'll show you with the close-up camera here. So I didn't have an 18 ohm resistor. I got a 8.2 and a 10 ohm. So that's going from the positive to here over to this pin. And then our negative just goes across and goes to that pin. So Grumpy Doc put a circuit board on there and a different kind of connector, but I just assume make it simple and reuse the old connector. So I took the old connector off the old display, and I didn't have the right size leads to put in there. I have the right shape. These are a little too big, and I need some smaller ones, so I dug through my spare wire box, and I came up with one. So that fits on here. So we can use that. So we just need to solder this to the board. And I think the last thing we need to do is mount the display. So we'll get on that, and we'll be back. Alrighty. I got the display mounted. Got the backlight cables soldered in. And the way I did this is this display is thinner, so I had to use some 1/4-inch standoffs because the mounting holes are, they're higher up off the board. So put 4 1/4-inch standoffs. I used some tiny thin washers to kind of shim everything up so it's level. And the mounting plates, I just used some PCB board. It's very strong, and I was going to use some aluminum, but I didn't have any kicking around, so I just used the PCB board, and it's nice and rigid, and it's nice and evenly mounted. The display is nice and true. So let me show you the dimensions for that if anyone wants to make these adapter plates. So the space here is it's 8.5 millimeters between the boards and 54 millimeters apart. So This is the 8.5 millimeters, and it's 54 millimeters apart where this cable comes in. Depending on what kind of cable, you gotta notch this out. You can't really see underneath there, but I had to notch that out. So let's see, is there anything else? Oh, with the so that inverter board, I mean, you could, I guess, just use the 5 volts directly from the supply to that board, but it's got a bunch of capacitors and chokes. I imagine that the original display used a fluorescent backlight, and all those capacitors and chokes clean up the noise from that. I don't know how noisy this is, but I just assume use the noise filtering in that. And anyway, let me get this thing back together, and we'll keep our fingers crossed that it puts some frequencies out. So we'll be back. All right, one more modification. The damn push switch is hitting my adapter plate, so I got to notch that out. So I got to take it all apart. We'll be back. All right, we got it all put back together. We have a display, but what's the damn thing put out? So got a scope hooked up. So let's see. Ten megahertz. RF level. Let's go with oops. It's the first time using this, so 1 dB. Huh. All right, I can't get any output out of this thing. Not good. I'm going to have to dig into the service manual and see what's going on. All right, we're making some progress. So we have a signal coming out of our RF board up here. And hopefully you can see that on this little scope. So it is the RF board's our last stage, and it goes into this attenuator board and the output. And yeah, that supposedly is not serviceable. It has a reverse voltage protection diode in it. I wonder if that's bad. I don't know if that is replaceable. But this is the last stage before it goes into that board. So have to look into that. Maybe post something on the EEV blog, because I'm not sure what to do on the other thing of it. On the other side of this, it's I have to take a big board out to even get to that board, which is a pain. So we'll see. I'll see what I can come up with. Alrighty, we got some progress here. I got some ribbon cable extenders, and I made this one for the power supply, or from the power supply. So in that last segment, I showed you the scope of where the RF comes out, and this is the attenuator board. I had to remove the board that was on top of it. It's here, mounted on a plywood jig out of the way. So where the probe is, right here, that's that same point, but on the other side, and it goes into the attenuator board. So I'll show you the I have it set to 5 megahertz, and it's coming out of the RF board, going into the attenuator board. And I thought initially it went all the way through to the final reed switch. I thought that was a problem with the protection circuit, keeping the signal from going through, but as it turns out, it doesn't get past the first switch. So let me show you here. So the signal comes in here, and this first switch, it should be switching our signal up, and instead it's switching our signal down into this deal. This is a switch, and it's the pulse modulator switch, and if that's activated, it switches off our RF signal through that resistor to ground, and that's exactly what's happening. So, and yeah, so let me show you. So this it comes out this pin 3 here. So I'll show you with the scope here where that happens, if I can do this. So pin 3, it's coming out pin 3. So for some reason the pulse modulator circuit is being activated. That's switching that switch in the wrong direction, and it's killing our RF signal instead of progressing on through the board to the output. So I need to figure out what's going on with that. So we'll do some more investigating, and we'll be back. Okay, I had originally said that the signal came in here, and instead of going up, it was switched down into this pulse modulator deal. And that is correct. And then I was talking about how it goes down there to ground out RF and all that, but that's really immaterial. It's these two switches that are at issue. So, what flips these switches? We got one set there, one set there. They are energized by these two sets of coils. There's a coil here, coil here, coil here, coil here. And one signal comes in, and actually this is wrong. This should be connected here. This is the schematic for the 2023A, which is a little bit cleaner to see than the original scan of the 2024. But anyway, one signal comes in and energizes these coils. If it's, I can't remember which one is which, but we'll say a high one energizes these coils and low energizes these coils. So, where do these signals come from? Good question. After much searching, I found that those two wires that went into that previous slide, there's one here and one here. And they are controlled by this switch. It's a 74HC595. I can't think of the exact name of it off the top of my head, but anyway, data's fed in from these 3 points, and the outputs are either high or low. So pin 15 connects to two separate transistors. One's an NPN, one's a PNP. So, when the signal is high, it goes to the NPN. We got 5 volts. It goes and energizes 2 coils, flipping our switch. If it's low, it goes in and energizes the other 2 coils, flipping the switch the other way. So our switch is stuck magnetically in low because those contacts are magnetic, and once they're switched, they stay connected. So that's the deal. We need to, my idea is to jumper the base and emitter and energize the switch to RF and take it out of the pulse modulation. So I don't care about replacing that transistor because it's in kind of a bad spot, and I don't plan to ever use the pulse modulation. So let me show you the measured voltages on the board. So let's see, where's a pointer? This is our transistor in question, C707. The top pin is the collector. The bottom left is the base, and the bottom right is the emitter. change my glasses here real quick. At the base, we have 5 volts. And our collector on top, that's got 5 volts. So that should be turned on. But at our emitter, nothing. So we're going to jump that. Hopefully that relay will click and we'll be good to go. So I'll get that set up and we'll be right back. All right. So here's our transistor. This is the collector and emitter that we're going to be shorting across. And essentially what I have is just a couple of meter leads, and I put a 100 ohm resistor in between. I'm not sure why. Just, I guess, in theory, to limit any crazy current that goes through there. We sure as hell don't want to burn up those coils. I doubt the mic will pick up if we hear that click, but I guess here goes nothing. It's not clicking. That is, I don't know. I got to think on this. All righty, fantastic news. I took that 100 ohm resistor across the contacts out. This is, I got so many wires here. Let me get it in the camera. So I just used a banana connector and had it together with the 100 ohm resistor and the 2 probes. And anyway, I deleted that 100 watt resistor and it clicked. And now you can see the output going to the scope. This is our attenuator knob. Oh man, I'll tell you what, days and days screwing with this, trying to figure this out. So that in theory should stay in place. I mean that switch position, because it's magnetically held into that position until it gets energized in the other direction. So holy crap. Wow. I believe the modulation is not working, or not. Maybe there's another switch. I have to dig into that, but this is just a huge relief that I got this part figured out. So on to the next repair with this thing. Okay, I thought the modulation was not working. It just turns out you have to hit the right frickin' buttons. So I got 455 kilohertz up there on the scope, and we have our modulation. So aside from that transistor, we're going to call this fixed. Oh, and I do need to recap it. So I'll do that off camera. That's no big deal, but big this is noisy. Big learning curve for me. This is way above my pay grade to be working on something like this, but in the end, we got it fixed. So I'm quite happy about that. I was really worried it was going to end up being a couple $100 heavy doorstop. Okay, got it all put back together pretty much. I still have to recap the power supply, but I'll do that off camera. I haven't posted a video in a little while, so I want to get this done. So just recapping a few things. Oh, I did look at some date codes on the ICs, and they were vintage 1997-ish. So that's, I guess, what I would date this thing to. So what are we fixing it? The first thing we checked was the power supply, and the positive 12-volt rail was low. And that had that bulging bad cap, so we fixed that. But that didn't fix our display. So we put a new display in from DigiKey, and we mounted it to fit since it wasn't the same dimensions, and had to do a little modification to our backlight power supply. And then I thought it was all fixed and fired it up, and there was no output out of the RF jack. So that led me down a rabbit hole of finally figuring out it was a faulty transistor that wouldn't switch our magnetic switches. They or wouldn't activate the coils to make those switches switch. So they are going to hopefully stay in that position. I don't plan on using the pulse modulation, so had a little help along the way from the EEV blog, and thanks to those guys that helped me do that. And this repair, like I mentioned earlier, way over my pay grade, but still managed to figure it out. I don't know if I explained it that great, but hopefully enough to make sense where a guy could dive into one of these. So it was a fun repair, though it was quite frustrating at times, and we got it working. The reason I wanted this machine is my handy HP only goes down to 455 kilohertz, and this one will go lower than that, so I can align some of the older vintage tube gear. So anyway, hope you enjoyed it, maybe learned something, and thanks for watching.